Hey, we're back. It is Unit 7-4, Solving Proportions. Hopefully you'll find this to be a pretty straightforward lesson, something you've seen well in your past there. Let's take a look first at our math career. How about a psychometrician? Psychometrician, you say, what in the heck's a psychometrician? Psychometrician is a person who practices the science of measurement, or psychometrics. The term psychometrics refers to the measurement of an individual's psychological attributes, including the knowledge, skills, and abilities a professional might need to work in a particular job or profession. These types of people analyze and figure out what people know and how they know it, and moreover, they can reverse that and figure out how to help people learn new material. A lot of them also work for agencies that write exams, and you can see the list of exams here. Some of those letters may look familiar and some may not, but you'll get there. You can see the salary there, pretty good, and of course it skyrockets there at the end there. That high-end salary is pretty healthy. You'll need a lot of math, as you can see there, but all quite doable if that's something you want to pursue. Alright, today we will learn to write and solve proportions, just like what you see there on our screen. Alright, so vocabulary today is going to be focusing on ratio, proportion, and unit rate. Ratio, proportions, and unit rates. So, a ratio is a comparison of two quantities. So, just kind of take a look here. I know that looks like the fraction 3/5. In a ratio, it's actually spoken as 3 to 5, or yeah, we can write it like a fraction, or we can write it in different ways. So let's take a look here. The ratio of girls, well, in this case, the girls to caterpillars, is 3 to 5. Pretty obvious. There's 3 girls there and 3 caterpillars there on the right-hand side. Ratios can be written in 3 different ways. We can write it as a traditional fraction, which is usually pretty convenient. We can write it using a colon between them, 3 to 5, or we can actually use the word 2, 3 to 5. So 3 girls to 5 caterpillars, 3 cats to 5 dogs, and so on. A proportion is an equation of 2 equal ratios. So now we're going to be looking at 2 ratios that are set equal to each other. Like this example, 3/5 equals 9/15. If you multiply top and bottom of 3/5 by 3, well, we'd get 9 over 15. Moreover, if you do the reverse, if you divide 9 by 3 and divide 15 by 3, we end up with 3/5 over here. Okay, so this is a proportion. In solving a proportion problem, you will have to solve for the variable in which one of the four, which will be in one of the 4 positions. For example, it could be in the upper left. You have x over 5 equals 9 over 15. It could be down there. It might be on the bottom left, or even the upper right. It's not going to make any difference. In the end, it's all going to work out. It just might include an extra step or two if we have one in a particular place. All right, just go ahead and watch this. If you can spot what we call an equivalency, you can go straight across as you would an equivalent fraction. For example, 5 over 11 equals n over 44. Well, right here, do you see a relationship between 11 and 44? Couldn't we multiply 11 by something to get 44? And of course we could. We could multiply that by 4. And remember, whatever you do to the bottom of a fraction, we must do to the top to have an equivalency. So what's 5 times 4? Well, that's going to be 20. So what does n equal? N equals 20. So 5 over 11 is the same as 20 over 44. Now otherwise, we're going to have to cross multiply. Now cross multiplication will always work. So if you don't want to worry about looking for equivalency, you can just always cross multiply. 5 times n is equal to 7 times 4, which of course is 28. Now to solve for n, we simply divide both sides by 5. And we end up with n equals 28 over 5. Don't be concerned about writing mixed numbers unless you're working with a real-world problem, like how many gallons of gas do we need, or how many laps are we going to run, or how many miles is it, or whatever. Then we would actually use a mixed number. But for now, just as a pure math problem, leave it just like that, 28 over 5. All right, how about this one? A little more challenging right out of the gate here. 6 over y minus 3 equals 2 over 7. So why don't you give that one a try there. Give you about, well, as much time as you want. But I'm going to stall here for a second and then start it up. So if you want to press pause, go ahead and see if you can get y there. All right, how about this? How about we cross multiply? I don't see an easier way to do this without going to too much trouble. So I'm going to cross multiply and cross multiply, and we're going to end up with 2y minus 6. You see where that came from? Remember, we're distributing that 2 through to the y and the negative 3. And what is 6 multiplied by 7? Well, that's 42. Now, of course, just like that, it's a nice easy problem. Get rid of the 6 first, add 6 to both sides, and we end up with 2y equals 48. Divide both sides by 2, and you're finished, just like that. So, of course, the only tricky piece here was cross multiplying and make sure you distribute. All right? Good. All right, how about a word problem here for us? A bag of concrete mix calls for 3 quarts of water to 40 pounds of concrete mix. How much water should be used if only 30 pounds of concrete mix are to be used? So in other words, you have concrete mix that, let's say they sell it to you in a bag of 40 pounds. So you can't really buy a smaller bag. 40 pounds is what you got. So you take that home, but you only need 30 pounds of it. So how do you handle the water mixture? Because too much water and it's not going to work. Too little water, it's not going to work. So you got to be right. So here's what we do. We end up looking at a proportion. We know that it's 3 quarts for the full bag. 3 quarts of water for the full 40 pounds. But we're not going to use the full 40 pounds. We're going to use 30 pounds of it. So we're going to say, well, how many quarts then for only 30 pounds of this mix? So we simply do this. We can cross multiply just like we know how to do. 40n equals 30 times 3, which is, of course, 90. Divide both sides by 40. We could cancel some zeros there if you want, but we end up with 2 1/4 quarts of water. Now this is an example where we would use a mixed number because we're solving a real-world problem. All right? Okay, so there, proportions. Cross multiplication will always work. If you see an equivalency, go ahead and take that. A rate is a ratio with both quantities or numbers are in different units. For example, 24 miles to 6 hours. Okay, so if you were to travel 24 miles in 6 hours, we could find a rate, couldn't we? How fast are we going? Well, that would be probably 4 miles an hour. A unit rate is a ratio with both quantities or numbers that are different units, and one of the units is 1. So, for example, 24 miles in 6 hours, that is exactly 4 miles for every 1 hour. How do we do that? Well, of course, we just reduce that denominator down to 1. We divided it by 6. We divide the top by 6. All right, that's it for Unit 7-4. There's some more instruction at the top, some practice at the bottom. We'll talk to you soon.